Okay. Exercise 4B is actually easier than you think. It looks hard, but it's actually much easier than 4A because it's just add and subtract. Now, 4B notes, I rewrote the 4 rules again for you to see. Now notice here, rule number 1 says that you cannot square, root of x plus root of y does not actually equal to root of x plus y. And the reason for it, if you think about it, is since surds are irrational numbers, we cannot add or subtract as we conventionally would with whole numbers. So for example, 3 plus 1. Okay, so that number system we are aware, we can use the number line to prove that 3 plus 1 is 4. But irrational is a different number system. Okay, we don't know what the square root of a certain number is. So for example, if I gave you root 2 plus root 3, the issue is I do not know what root 2 is. I can't write it as a decimal, I can't write it as a fraction. Neither do I know what root 3 is because they go on infinitely, right? So that's why I can't add them traditionally. But what we do know is they both have to equal to something. True? But whatever they equal, they're definitely not the same. Root of 2 cannot be the same as root of 3. So what you can think of as, you can think of root 2 as the letter A. It's a number. You can think of root 3 as a different number. Let's call it B. See, if you treat it like A's and B's like algebra, then it makes really good sense on how you add. So you can only add algebra like terms with like terms, right? So with surds, it's the same idea. You can only add surds that are of the same radical surd. And you can't add surds of different radical surds. So here's an example for you to visualize. So if I gave you this, and I asked you, what is 3A plus 7A? What would you say? 10A. And the reason why you know that is because 3A, notice 3A, we don't actually know the number. I actually don't know what 3 times A actually equals to, just like I didn't know what root 2 was. But 3 next to an A means 3 times A, so I wrote it here. That's 3 times A. 7 groups of A, so 7A means 7 groups of A, is over here. What's interesting is that if you wrote it out, expanded it, that is the same thing saying A plus 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 A. I think that's 7 there. We go. Can you see that's 3? And that's 7 over there. So that means that we have 10 of those A's. Alternatively, another way to think about it is they both have a factor of A. And remember back then you learned to factorize? We can factorize out the A. What goes inside the brackets?
10.
Well, yeah, it is 10, but it's 3 plus 7. Yeah, so remember, you can factorize it out. It'll be A groups of 3 and A groups of 7. That's how you get 7 groups of A and 3 groups of A. Yeah, so remember how you expand brackets back then? If I gave you 3 bracket A plus B, you would have said 3 times A, 3 times B. Well, I'm doing the same here now. I'm saying, well, A times 3 is the same thing as 3A. A times 7 is the same thing as 7A. True? But what's nice here is by doing that, you can see where A is separated and 3 plus 7, I got 10 of those A's. Now, if you look onto the right-hand side, it's exactly the same with surds. See, I can say, what is 3 root 2 plus 7 root 2? I don't know what root 2 is. Just like I don't know what A is. We don't know what A is. They're exactly the same things. This root 2 is a number that I don't know. And this root 2 is also a number that I don't know. But what I do know is they're both the same. So if I got 3 groups of this root 2, so I'm going to fill it in, and I've got 7 groups of this root 2, and if I factorized it out, it should be the same idea. It should still be root 2 at the front, and then 3 plus 7 in the brackets. 3 plus 7 I can add conventionally because they're both rational numbers. 3 plus 7 is 10, and so my answer is 10 root 2. This is the proof to the understanding of addition and subtraction of surds. And the idea is you cannot add surds that are not the same. Just like algebra, you cannot add different like terms. They have to be the same letters for you to add. So same thing with surds. You cannot add them if they are not the same surds. So Therefore, you can only add or subtract like surds. That is the key understanding of exercise 4B. Let's do an examples just so that you can get a feeling of this, okay? So let's have a look. Let's look at the first one. I don't know what root of 5 is, but I know I got 2 of them. Then I'm adding on another root of 5, but I got 3 of them. Are these like surds or not like surds? They're like surds. They're exactly the same groups. So because of the same groups, I got 2 of these plus another 3 of these. Well, together I should now have 5 of those root 5s. So you can only add surds that are the same. Let's look at B. Can you see in B, I have 2 different types of surds. I've got a root 7, which I don't know, but I also have another root 7 over here that I don't know. Those 2 are like surds. Root 3 I don't know, but I know it's different to root 7. So these root 3s are like surds. So if you treat them like letters or like pronumerals the way you did with algebra, you can call it like 3a plus 2b minus 2a plus 5b. That might make your life a bit easier. Yeah, because it's the same idea. We just don't know what a's are and we don't know what b's are. We don't know what root 3 is and we don't know what root 7 is. So if you add them together, let's simplify it. Root 3 root 7 minus 2 root 7. I know they're like surds, so I can minus them. What's 3 root 7? Take away 2 root 7. Very good. Now, just like algebra, we don't write the 1 at the front. We just write root 7. But you can write 1 root 7 if you want to. Okay, we just don't traditionally write that. Just like 1x, you don't normally write the 1 in front of x. The next one, 2 root 3 plus 5 root 3. 7 root 3. And you can't add those 2 together. So with my mainstream, usually they'll write their answer as 7 root 10. And that's when I know they don't understand it. So you can't add the surds. Root 7 plus root 3 are not the same numbers, and you don't then combine them. So that's wrong there. That's your final answer. Root 7 plus 7 root 3. Okay? Oh. All right. Now, let's have a look at C. C now combines a bit of 4A. Can you see if you look at C, 7 root 2 minus root 8, are these 2 like surds? No, at the moment they're not. But root 8 you can simplify. If you simplify root 8, what 2 numbers, whereas one of them is a square number? 4 and 2. That's the same thing as writing root of 4 times root of 2. But root of 4 we know is 2. So 2 root 2. Suddenly, now you have 7 root 2, take away 2 root 2, and they are now like surds. So these 2 are like surds. They're both root 2, so your answer must be 5 root 2. Very good. I'm going to pause the video and I want you to try D yourself. And I'm pretty sure that is it for today. The fractions part, you can take your time, but if you can add, subtract numbers, then you can do it with fractions as well. But I'll give you 90 seconds to do D. I'm going to pause the video. Here we go. If you simplified it correctly, root 3 is a prime number, so that's as small as you can get. 27 can be 9 and 3, so that's 2 root of 9 times 3. And this is root of 4 times 3. Conveniently, that will then make it take away 2 times 3 root 3 plus 3 times the 2 times root 3. I skipped a step. I did the square root of 4, that's how I got the 2. And I did square root of 9, that's how I got the 3. And that gives me 2 root 3, take away 6 root 3, plus 6 root 3. Well, these 2 are going to cancel out. Negative 6 plus 6 cancels out. So you get 2 root 3. Hands up if you got this correct. All right, well done. That's exercise 4B. And that mixes in 4A. So 4A simplified, 4B is to add, subtract. If you are game enough, you can try fractions. Otherwise, that's it for today.